In the summer heat of Mongolia's Gobi Desert, a team of paleontologists noticed something strange: bones sticking straight out of a cliff face. What seemed like ordinary rock turned out to be a near miraculous find. Encased within was the partial skeleton of a dinosaur no one had seen before. The specimen, later named Zavacephale rinpoche, represented the earliest known dome-headed dinosaur, or Pachycephalosaur, with more than half its skeleton preserved, including an intact domed skull. Sections of limbs, and even stomach stones, this fossil instantly stood apart. For decades, dome-headed dinosaurs were known primarily from the late Cretaceous of North America, with Pachycephalosaurus standing as the most famous. But here, in the Gobi Desert, was a species more than 20 million years older. Its discovery not only extends the history of dome-headed dinosaurs, but also reshapes our understanding of how these strange, thick-skulled creatures evolved. For older audiences who grew up fascinated by head-butting dinosaurs, this is a rediscovery of childhood wonder, except now grounded in cutting-edge science. A bone jutting from sandstone has rewritten the family tree of Pachycephalosaurs and raised new questions about how and why these animals developed their bizarre anatomy. To appreciate Zavacephale, we must explore the broader timeline of Pachycephalosaurs. Most were small to medium-sized herbivores, characterized by thickened skull domes. In popular culture, they're depicted as headbutters, charging at rivals like prehistoric bighorn sheep. For years, these dinosaurs seemed confined to the late Cretaceous, about 70 million years ago, particularly in North America's Hell Creek Formation. That created a puzzle. Did Pachycephalosaurs suddenly evolve late in the dinosaur story, or were their ancestors hiding in earlier rocks, unrecognized? The Gobi Desert discovery answers that question. At 108 to 115 million years old, Zavacephale pushes back the lineage by tens of millions of years. This places dome-headed dinosaurs firmly in the early Cretaceous, proving they had a much longer evolutionary history. It also shows that Asia played a central role in their development. The Gobi, often compared to America's Hell Creek, is one of the richest fossil landscapes on Earth. For American viewers familiar with Pachycephalosaurus, this find acts like a prequel, showing us the dawn of a dinosaur design that would later dominate Cretaceous ecosystems. The journey from Triassic beginnings to Cretaceous peaks is now more continuous than ever before. The Gobi Desert has long been legendary in paleontology. In the 1920s, Roy Chapman Andrews led American expeditions that uncovered the first dinosaur eggs ever found, forever linking the Gobi with groundbreaking discoveries. Nearly a century later, the desert continues to surprise. During a survey of cliffs and sandstone ridges, paleontologists spotted bones protruding from weathered rock. Careful excavation revealed something extraordinary: more than 4% of a single skeleton preserved in life position. This level of completeness is rare for Pachycephalosaurs, whose fragile skull domes often weather away. The fossil included not just the iconic dome, but also vertebrae, limb bones, ribs, and even gastroliths, small stones swallowed to aid digestion. The name Zavacephale combines Zava, a Mongolian term for dome, with cephal, Greek for head, while rinpoche is a respectful Tibetan word meaning precious one. This combination reflects both the anatomy and the cultural heritage of the region. For scientists, the completeness of the specimen allows for detailed anatomical studies. For the public, the image of a dinosaur skull literally sticking out of a cliff is irresistible, conjuring scenes of lost worlds waiting beneath desert sands. The Gobi once again proves itself as a land where the past rises to the surface. What makes Zavacephale so distinctive? Its most striking feature is the thickened dome of the skull. Unlike the flatter heads of early relatives, this dome is strongly arched. Though smaller than the massive structures of late Cretaceous species, the surface shows vascular grooves, evidence that bone was actively growing, thickening over time. This suggests that the domed skull was not just a late innovation, but an ancient trait, already present in early Pachycephalosaurs. Beyond the skull, the skeleton reveals a small to medium-sized herbivore, likely around 1.5 to 2 meters in length. The forelimbs were short, the hind limbs longer and muscular, adapted for quick bursts of speed. The presence of stomach stones indicates a plant-based diet, with the stones helping grind tough vegetation. Interestingly, the teeth are leaf-shaped, perfect for slicing through ferns and cycads. Together, these traits paint a picture of a nimble, fast-moving dinosaur that combined defensive anatomy with efficient feeding adaptations. In essence, Zavacephale was an early experiment in the Pachycephalosaur body plan. For comparison, Pachycephalosaurus grew over 4 meters long, with domes up to 25 centimeters thick. Zavacephale was modest by contrast, but it laid the foundation for the head-butting titans that followed. Why is Zavacephalus such a breakthrough? For decades, paleontologists debated when Pachycephalosaurs first appeared. The fossil records seem to show a sudden late burst in the Cretaceous, as if these dinosaurs had evolved rapidly and mysteriously. But the discovery of Zavacephale pushes their origins far earlier, revealing a gradual buildup instead of a sudden arrival. This matters because Pachycephalosaurs belong to the ornithischian branch of dinosaurs, alongside ceratopsians like Triceratops. The early dome of Zavacephale suggests that head ornamentation was already important much earlier in evolution. It also opens new questions: were domes used for combat, display, or both? Some paleontologists argue that younger Pachycephalosaurs fought by butting heads, while others believe the domes served as visual signals. With Zavacephale, we can study whether vascular growth patterns hint at rapid thickening during adolescence, supporting the idea of sexual display. The fossil also connects Asia and North America. During the Cretaceous, land bridges allowed dinosaurs to migrate between continents. The presence of an early dome-headed dinosaur in Mongolia suggests that later North American species may trace their ancestry back to Asia. In other words, Zavacephale is not just a local discovery, it is a global key to dinosaur evolution. The Gobi Desert has earned its reputation as a treasure chest of fossils. From velociraptor locked in combat with protoceratops to entire nests of dinosaur eggs, it has consistently yielded iconic finds. Zavacephale continues this tradition. For Mongolia, the discovery strengthens national pride in its fossil heritage. Local scientists have been central to the excavation, analysis, and interpretation, ensuring the work reflects the region's ownership of its prehistory. For American audiences, the Gobi holds nostalgic ties to Roy Chapman Andrews, often cited as an inspiration for Indiana Jones. Andrews's dramatic expeditions in the 1920s captured imaginations worldwide, bringing images of camel caravans, desert storms, and fossil eggs into newspapers. Today, modern teams echo that legacy with advanced tools, but the same sense of adventure. The rediscovery of a dome-headed dinosaur here deepens the narrative of the Gobi as a crucible of dinosaur evolution. It also highlights the importance of international collaboration. American and Mongolian scientists have worked side by side for decades, piecing together the ancient ecosystems of Central Asia. For viewers over 40, this continuity connects the thrill of childhood adventure stories with the reality of ongoing discovery. The desert remains, even now, a place where prehistory comes alive. Picture an early Cretaceous morning in the Gobi. The air is cool, the sand tinted red by sunrise. Small herds of Zavacephale move together across scrubland, their domed heads catching the light. They feed on cycads and low shrubs, clipping vegetation with leaf-shaped teeth, then grinding it with the help of swallowed stones. Suddenly, two males lift their heads. They face each other, displaying their domes. With a burst of energy, they clash, skulls cracking together in a muffled thud. Dust rises as they push, testing strength. Whether these contests were serious fights or ritualized displays remains debated, but the effect is clear. Domes mattered. They signaled fitness, status, and mating potential. Nearby, juveniles with smaller, flatter skulls watch and learn. In the distance, danger lurks. A raptor-like predator prowls, scanning the herd for stragglers. But the Zavacephale are quick, darting on long hind limbs to safety. The landscape itself is harsh. Summer heat scorches, winter nights freeze, and sudden storms lash the desert. Yet, in this precarious environment, Zavacephale thrived by combining speed, group behavior, and unique anatomy. For viewers, this snapshot transforms bones into living animals, revealing not just anatomy, but drama. The dome was not merely bone, it was a symbol of survival, rivalry, and identity. How do scientists study a fossil encased in desert rock? Today, technology offers answers Victorian paleontologists could only dream of. CT scans allow researchers to peer inside the dome without cutting it open, revealing patterns of growth and internal bone structure. High-resolution imaging can detect vascular canals, showing how blood supplied the thickening bone. These clues suggest the domes grew rapidly in adolescence, supporting theories of sexual display. 3D modeling lets paleontologists simulate head impacts, testing whether domes could absorb blows without fatal injury. Results are mixed. Some species appear suited for combat, while others seem built mainly for display. Geochemical analysis of stomach stones provides evidence of diet and habitat, confirming that Zavacephale lived in a tough, arid environment where stones aided digestion. These techniques demonstrate how even a single skeleton can yield vast amounts of data. For the public, it highlights the power of modern science to bring ancient bones to life. For American audiences, it mirrors discoveries in their own museums, where reanalysis of old fossils often reveals new insights. The marriage of technology and fossil evidence ensures that Zavacephale will remain a focus of research for years to come. Why does Zavacephale matter beyond paleontology? Because it shows how forgotten landscapes can suddenly become central to science. For Mongolia, it strengthens a national identity tied to deep time, inspiring pride and drawing international attention. For the global public, it reignites fascination with dome-headed dinosaurs once dismissed as oddities, now revealed as survivors with ancient roots. For older audiences, it connects nostalgia with novelty. Many remember children's books or museum displays depicting Pachycephalosaurus as the budding ram of the dinosaur world. Now, Zavacephale adds a new chapter, showing that the story began much earlier and in a very different place. It also highlights the importance of museums and fieldwork. Without careful excavation and preservation, such fossils might never be studied. The discovery encourages support for scientific research, cultural heritage, and education. For Americans, it prompts reflection on their own fossil sites, just as Mongolia's Gobi yielded treasures. So too have formations like Hell Creek or Dinosaur National Monument. Both regions tell stories of resilience and rediscovery. In the end, Zavacephale is not just a dinosaur, it is a cultural ambassador, bridging continents and generations through the shared wonder of prehistoric life. The legacy of Zavacephale Rinpoche is profound. From a skull dome jutting out of a cliff. Scientists reconstructed the earliest known Pachycephalosaur. Its discovery extends the family tree, links Asia to North America, and challenges assumptions about dinosaur evolution. More broadly, it illustrates three lessons. First, that evolution is gradual, with roots stretching deeper than once assumed. Second, that even in the harshest deserts, fossils wait patiently to be uncovered. And third, that science is never finished. Every discovery raises new questions. Did Zavacephale truly butt heads, or was its dome a colorful display structure? Were herds cooperative, or were males fiercely territorial? Future finds may answer these mysteries. The Gobi Desert, still vast and only partly explored, holds untold potential. Perhaps more early Pachycephalosaurs lie beneath its cliffs, waiting to extend the lineage even further back. For audiences worldwide, especially those who grew up enthralled by dinosaurs, the story is inspiring. A chance discovery, half buried in sandstone, has rewritten our understanding of an entire group of dinosaurs.